Okay, in this video I'm going to work through a handful of the questions from this week's quiz, our check over understanding for our equations and inequalities. I think for now I'm just going to work through the even numbers on this list, and if any of the odd questions catch my eye, then I'll work through them as well. Well, we kind of started off this week reminding ourselves of how to evaluate expressions, and in this particular case we have an x value that's supposed to be equal to -1, a z value equal to -6, and so my recommendation is to substitute these into the expression using parentheses. Now if those parentheses are a bit confusing, then that's okay to drop them, but I do like using them because it does capture our negative values pretty well, and we can see exactly where the negative signs are and how they differ from subtraction signs. In this case, we don't have any of that, so I'm going to leave this -1 here. We're not subtracting, I should say. The absolute value of -6 does turn into +6, and when we multiply these together, the result of this expression would be -6. In a question like 4 or 3, we're solving an inequality, and we tend to solve these much like any other equation, only this time we have to remember that if we have to multiply or divide by a negative number to isolate our variable, which it looks like we're going to have to do in this case, then we do have to change the direction of our sign. So when we divide both sides by -11 to isolate this value n, now the math on the left side doesn't behave any differently. We still have a -132 divided by -11, which leaves us with 12. And we still have on the right side an n value, which has now been isolated because these fractions have reduced to 1. The only difference is that we have to change the direction of our sign. Instead of being a less than result, it becomes greater than, and we would report the solution as 12 greater than or equal to n, or if you prefer to rewrite it, n would be less than or equal to 12. We talked about this in class 2 this week. If you want to avoid dividing by negative numbers, you can certainly add across this inequality and obtain the same result as well. On our number line to represent the solution, however, we're going to indicate 12, which is included in our solution set, and all numbers that are less than it. So we'll highlight to the left of that. Now in a question like number 6, again our goal is to isolate the variable. In this case it's inside of an inequality, but before we get there we should move any other numerical quantities away from this side of the equation to get that to get that absolute value all by itself. So I'm going to subtract 7 from both sides, and we're left with n plus 7 is equal to 2. And at this point, now that we have the absolute value isolated, here's where we have to consider what would happen in both cases. If n plus 7 is equal to +2, we can solve for n, but let's not forget that n plus 7, that expression could be equal to -2, and if that expression was equal to -2, then the absolute value bars would return back to this +2 result. So we've now split this into two equations that we can finish solving. N would be equal to -5, or n would be equal to -9. And we see kind of a similar problem set with both 7 and 8, although in this case we have an absolute value with an inequality, and we see that in 9 and 10 as well. So let's remind ourselves of some rules we talked about in class. If we encounter an absolute value expression that's less than a particular number, then that implies that we're talking about an and combination between the two expressions. So when we split this apart into two, we're looking for the overlap or intersection of solutions. And that also is good for an equal sign as well. If the absolute value expression is greater than a target value, then that implies that we're dealing with an or scenario, and the distance from the distance our solution is from 0 ends up being greater than or bigger than a unit, so it generally points away from our target group. So in an example like number 8, since we have this expression inside the absolute value bar less than 2, this becomes an and problem set. I'll fit it down here. So simultaneously, x greater than 2 has to be less than 2, and x, divided by 2 is greater than negative 2. So because it's an inequality, we're setting up the expression equal to both a positive quantity and a negative quantity. Since we are changing the direction or changing the polarity of this number, we have to change the direction of this sign. And we'll solve both of these inequalities and look for where they overlap. So in this case, when we multiply by 2, we have x must be less than 4. And when we multiply 2 here, x must be greater than negative 4. So where would x be greater than negative 4, but also less than 4? Well, I'm going to identify 4 and negative 4 on the number line, and the region that's greater than negative 4 is pointing to the right. The region that's less than 4 is pointing to the left, and so just this region in between is going to be highlighted, and that's what we'd expect to see with a statement like "and" for these two inequalities. In a problem like 10, I see that, well, we have some numerical values to move first, but when we get this expression isolated, we have a greater than symbol. So this is telling me that we're going to be dealing with an or, as long as I isolate in that order. So here we go. I'll just copy this problem and then we'll work through it. First thing that I'm going to do is add 8 to both sides because I'm working to isolate the absolute value. So we have 10, absolute value of negative 8n. We're adding 8 to both sides, so we now have greater than or equal to 80. Next, we'll divide both sides by 10 to isolate the inequality. So negative 8n has to be, we're not changing the sign's direction yet. We'll just divide by regular 10. That gives me an 8. And now we have an absolute value that can be written with the 8 and negative 8. Both expectations should be met. So negative 8n should be greater than or equal to 8. Or, and again I'm using or here because we have our absolute value expression greater than a target value. And the other phrase would be negative 8n, and I have to change the direction here because I'm changing the value of my 8 from positive to negative, and we can continue to solve. So I'm going to divide both sides by negative 8, and that's interesting because since I'm dividing by negative 8, we're going to go ahead and switch our signs here. N has to be less than or equal to negative 1. Or when I divide by negative 8 here, negative 8 divided by negative 8 becomes positive 1, but I change the direction of the sign, and n would be greater than 1. So these two don't overlap. If I look at positive 1, I have to use a filled in circle here. And if I look at negative 1, the values that are greater than positive 1 are pointing to the right. The values that are less than negative 1 are pointing to the left. Those two expressions don't overlap, which is totally fine because with an or command, we're not looking for overlap, but we're looking for a combination of both inequalities. So the combination of both of these produce this group of numbers, 1 and larger, negative 1 and smaller. The only numbers that don't solve this inequality are there in the middle between negative 1 and positive 1. Now to finish out the examples in this chart, we have some slope-intercept form equations that we're trying to produce, and each one's slightly different. Sometimes we're given the slope and an intercept, sometimes we have a slope and some other point on the line. Here we have the equation in point-slope form, and here we have the equation in standard form, and each of these should be resolved into slope-intercept form. So this first one that I'm going to complete is remarkably simple. We know that the format is y equals mx plus b. So as long as we have the slope of the line and the y-intercept numerical quantity, then we should be able just to fill everything in. And that's what we have here. So y equals negative 1, x plus 1. You can leave that as it is. You could also report this as negative x plus 1, and that's totally fine. Side note, the worksheet generator that I've used here is calling the y-intercept just a numerical quantity, which is fine, but let's not forget that the y-intercept can be written, and often is written, as a coordinate itself, where all x values of a y-intercept coordinate will be 0, and the y value will be the numerical quantity indicated. So that's just a side note in case you see that written differently on a different set of homework. With number 14, we have the slope, so we know that m is equal to this, but for our coordinate, we have just some arbitrary x1 and y1 value. We don't have the actual y-intercept. So if we have an arbitrary point, and we have a slope, then we have to go through the point-slope formula. And that looks something like this. Y minus y1 is equal to m times x minus x1. We'll replace the y1 and x1 from the coordinate that's supplied, and we'll replace the m value with the slope that's supplied. So y minus negative 5 equals negative 3/5 times x minus 5. And for all intents and purposes, this is a linear equation that represents the line through this coordinate with that slope. But the instructions did ask us to simplify this and write it in slope-intercept form. So we'll go ahead and simplify and make that happen. So this left side becomes y plus 5. If I distribute here, that math isn't too bad. Negative 3/5 x. Plus, because the two multiplications of negative signs, and this 5 over 5, this turns into plus 3. I'm running out of room, so I'll finish up over here. Add 5 to both sides. Subtract 5 from both sides, and we have negative 3/5 x minus 2 as our slope-intercept equation. So that problem is very similar to what we're seeing here in number 16. I think we might end up with a fraction as a result on this one, though. So I'm not going to mess with this y minus 3 at first. I'm just going to distribute with multiplication here on the right side. So we have 2/3 x minus 2/3. Now we'll add 3 to both sides. And I'm not sure how comfortable you are with adding fractions. Some of you can do this mentally, and some of you will need to write it down. But if you want to see the process, if you're going to write it down, let's recall that a number 3 is equal to 3 over 1 times 3/3. I'm choosing this 3/3 because I'm trying to force a common denominator of thirds. And so if the whole number 3 times 3/3 is used, then we have 9/3. And so to combine negative 2/3 plus the 9/3 that I'm bringing over to the right-hand side, we have a positive 7/3 as a result. Now, a calculator doesn't really need to be used for these questions, although some of them can be tricky. So we're going to continue to practice these problems in class to get ourselves comfortable to solve them without a calculator. But if you need them to check your work on this assignment today, I'm okay with it. Now I could finish with 18, but number 17 looks a little bit more interesting to me, so I'll finish this one here. Recall we have an equation in standard form currently. Our job would be to isolate y. This is a lot like what we saw during the first review of this week, where we were solving literal equations. And literal equations were those where we would isolate for just some letter, any arbitrary letter in an equation. This time we're going to solve for letter y. We're going to try to get it by itself. So when I look at that, I have a group 3x that's subtracting an 8 times y. So I'm going to move this 3x as a whole group to the right first. Then I'll find a way to move this negative 8, and that should give us an opportunity to have y isolated. When y is isolated, we'll have our slope-intercept formula. So I'll move this 3x as a whole group. Remember, I'm not splitting these apart, but I'm going to move this as a whole group positive 3x on the left-hand side should be subtracted to show up on the right side. So I have a minus 3x plus 14. I'm not writing this as 14 minus 3x here because I want this result to look more like our regular slope-intercept formula. So I'm not going to leave it like this. I'm just going to automatically rewrite it this way. There we go. Now, to isolate y, we're not moving the y. We want it to stay where it is. So I'm just going to break apart this term, and I'm going to divide both sides by -8. So if both sides are being divided by -8, that implies that each of these terms is being divided by -8. And we've got a pretty decent expression. This looks okay, but let's not forget we should simplify whenever possible. And the fraction -3/8 is already simplified. It's been reduced as far as it can go. But in the second fraction, we have a common factor of 2. So if I divide both of those by 2, I have 7/4. And the fact that we've got a positive 14 and a -8 returns us a negative result. So I'll go ahead and call this minus 7/4. Okay, so I'm going to stop the video here. I'll let you finish up the other problems on your own now that you've seen examples of pretty much every kind. If you have further questions, please reach out to me by email, or we'll talk about it next time we see each other in class. Thanks for watching.